All right, guys, this is exciting stuff. We've gotten through the bulk of the early part of chapter 1, which is all about graphing quadratics. And we're going to start talking about solving and what it means to factor, okay? So this is something that we would probably consider standard form, right? You guys, ax squared plus bx plus c. And we talked about how we can sort of convert these things into intercept form, like this. Well, this process is what we're going to call factoring, going from standard form to intercept form. Let's go over some vocab really quick. I want to talk about what a binomial is. Okay, it's the sum of two monomials. So x is a monomial, 3 is a monomial. We now have x plus 3, y plus 8. Now it's a binomial. So these are binomials, right? Two pieces. And you could probably guess all quadratics are trinomials because they have 3 slots, right? 3 spaces. So we're going to consider every quadratic as a trinomial, even if you see something like x squared plus 2, because really what this means is x squared plus 0x plus 2. That there's no x's, but we can still think about it in terms of there's 3 degrees to it, x squared, the x, and then the constant term. So we still consider it a trinomial. So factoring is the opposite of FOIL. First, outside, inside, last, where you multiply two binomials together to get a trinomial. So it's the art of taking a trinomial and we're going to turn it into two binomials. Let's see about what it really means to factor. Okay, think of it as breaking something into its pieces. So you guys know how to do factors of regular numbers, like factors of 24 could be 3 and 8, 6 and 4, 12 and 2. Well, trinomials have factors as well. Okay, it's going to be the binomials that when you multiply them together get you that trinomial. So a foolproof method of this is the table method. That's what I'm going to work with today. Some of you guys will find that over time you're factoring so much that you start going, I can do this in my head. I've seen this pattern before. I know exactly what it is. But I've found that doing the table method is essentially foolproof. And so let's walk through it. All right. It's important to note that not everything that we do is factorable. Okay. This one, number 2 here, I believe, is an example of something that isn't going to be factorable. I'm pretty much going to give you things that are factorable, especially this early. And we're going to talk later in the chapter about what happens if you try to factor something that you can't. Let's focus, though, on factoring what we can. All right. I need to turn this into two binomials that when I multiply them together gets me this trinomial. So the first and most obvious thing is that I need to be getting an x squared. And the only way that that is possible is with an x term times an x term. It's the only way that's possible. Now, because I have x's in these slots here, that means that whatever is here will have an x, and whatever is here will have an x, right? That this column will have an x, and this row will have an x. And what goes right here needs to be negative 18, because I'm going to have like a number here and a number here. So that represents, like in terms of foiling, this represents the last term times the last term, number times number. So this is where our ability to factor a trinomial is also going to hinge on our ability to factor a number like negative 18. So what are some factors of negative 18? Well, the obvious ones are I could do 18 times negative 1, or I could do negative 18 times positive 1. I could also do 2 times negative 9, or negative 2 times positive 9. I could also do 6 times negative 3, or negative 6 times positive 3. So there's my list of possible factors. All of them, no matter which pair I pick, they'll all get me this correctly. That's why they're on the list, is because they multiply to negative 18. But not everything on this list will combine. Look at these green ones right here, right? They're going to be like terms. So they're both going to have an x. Number times x, number times x. They need to combine to negative 3. So these ones, when I add them together, nope, 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 Nope. Okay, 6 minus 3 is positive 3, but that's not what I want. I want negative 3, so it's got to be this pair right here. Negative 6, that way I get negative 6x, and positive 3, that way I get 3x. And what happens when I combine these like terms is that I get negative 3x. So what does this look like in factored form? X plus 3 times x minus 6. Right? So looking at this one and like why it can't be factored, you guys, 9, if I were to try to split up 9, 9 times 1 or negative 1 times negative 9, 3 times 3, negative 3 times negative 3, those are the only factors that work, and none of them add up to the middle term. So sometimes you can break down that last term and split it up, but none of the possibilities get you that middle term. And that's okay. You would just write, oh, it's not factorable. But to be honest, I don't know how much time I'm going to spend with things that aren't factorable. I'd rather have us focus on stuff that is factorable. So let's do some more practice as a class. We have a lot of options here. I believe in class what I had us do was I had you guys sort of shout out some ones that you thought would be a good idea for us to do. I think the one I'm going to go with right now is number 9. I'm going to do number 9 together, and then we will wrap up this video. So when I look at number 9, here's what I want to jump to doing with some degree of immediacy, is say b times b is b squared. That I need to have negative 40 in here, so I need to start listing factors of negative 40. And this is where I'm going to start encouraging you guys to be as clever as you can. So I noticed that my middle term here is a positive. My end term here is a negative. So I must be multiplying a positive times a negative, and I need the positive number to be bigger. So like, is it possible that I could do negative 20 and positive 2? Sure, but I want a positive number when I combine these for my middle term. So I'm not even going to bother wasting my time in writing it. Right? So what I mean by that is like 10 times negative 4. I don't need to worry about negative 10 and positive 4 because that would get me a negative number. That one's not going to work though. What else could I do? What else could I do? Oh, I know. How about positive 8 and negative 5? That's my option because 8 minus 5 is positive 3. So factored form, b plus 8, b minus 5. And that's a wrap. Tomorrow we'll talk about what it means to solve these problems, what it means to